So the goal of this lesson is to be able to support an argument that the reason that there's a difference in apparent brightness of a star from the sun is because of the distance from Earth. So there are some key vocab words and terms I want to go over. Some of these you will have seen before, and a couple of them might be new. But these are going to be helpful to you in your understanding of what it is that you're going to be doing. So first we're going to cover the sun. As fifth graders, you all know what the sun is. It's at the center of our solar system. It produces light and energy and heat for us here on Earth. So in your definition, you're going to write it's a star. And like all stars, it produces light and heat. Then you're going to draw a picture. And you're going to draw the sun. And I want you to put the Earth next to it, because this is our star. It is our sun. We only have one sun or one star in our solar system. So next, we're going to give a definition of a star. It is the exploding ball of gas held together by gravity. Now we can go more in depth in this definition, and you probably will in your research. But this is where we're going to start. This is the foundation. And I just draw, it looks very similar to my sun because the sun is a star, right? So as you can see, there's no Earth. So however you want to depict that in your picture, that this is the star, and maybe you draw more stars next to it in different sizes, whatever is going to help you understand that this star is a different star than what our sun is. So we know that stars produce light, and that is what we can visually observe here on Earth. So here on Earth, when we observe a star at night, we're seeing how bright it is, and we're going to call that apparent brightness. Now there is a second term. It's called true brightness. So apparent and true. When we're talking about apparent brightness, we're talking about the brightness of a star as you can see it from Earth. So that's what I want you to write here in your definition. Earth is a bit, you can make it big if you want to so that you understand it's from Earth. But you're also going to draw something in your picture that depicts that as well. So here in my picture, I put a little person on a world, and now I understand this is not to scale. We are not larger than the Earth, and I feel like these look like fried eggs, but ignore that. You know that this is a person on the Earth, and these lines mean that they're observing these stars from Earth, and they're seeing this wavy part around the circle is its brightness. That's its apparent brightness because we're observing it from Earth. The true brightness would be if we got up close and personal with that star to see its actual brightness. The closest that we have come to seeing actual brightness is when we view the sun during the day. And that's still not actually seeing its true brightness, because the Earth is how many miles away? Oh gosh, 95 million miles away from the sun. So we are still not seeing its true brightness. So if that gives you some context, some background as to what you're observing at night and why, you might want to start thinking about that argument as to why there's a difference. So here in my picture, I drew my sun or my star, whichever one, and I drew my person out in space, because you'd have to get up close and personal, and then they've got some camera and their little notebook to take some data so they can do some measurements of its true brightness. Okay, so apparent brightness is what we see from Earth. This is what we see in the night sky. And then true brightness would be if we took a rocket ship and traveled to the sun and decided to look at the sun from there, right up next personal. I did include solar system. As fifth graders, this again should be a review for you, but I wanted to give you context as to the scale of what we're looking at here. So the solar system, you're going to write, it consists of our star. So one star is in our solar system, and it's all the objects bound to it by gravity. So planets, dwarf planets, comets, asteroids, the Kepler belt, all of that is a part of our solar system. From the sun to the edge of our solar system, it's about 1.8 light years. Now what's a light year? A light year is how far light travels in 1 year. Now we know light travels fast. That's 6 trillion miles. Okay, so the edge of the solar system is 1.8 light years. And then beyond that is the stars that you are viewing at night. So those are our key vocab to get you started. From here, you will have more intensive definitions and understandings as you do your research, but this should help you lay some groundwork for your research and able to support an argument.